Okay, hello everyone, can you hear me? Okay. So I simply share my screen. Okay, can you see my screen now?
Yes.
Okay. So hi and welcome to the third day's online training session on Google Earth Engine for remote sensing analysis. We already covered our first day and second day, and today is our last day. So basically, today I am course coordinator, and third day course content will be that I will try to discuss about that how you can easily computation using satellite images. Suppose when you want to calculate the different types of indices, how you can easily calculate the NDVI, NAWI using the satellite images band. How you can easily calculate it using this band, different types of indices. And then we also try to discuss about the introduction to the land cover classification map. Actually in this time here I discuss you the supervised machine learning method, how you can easily using the supervised machine learning method and created the land cover classification map using the Google Earth Engine platform, and then make the LULC map in Google Earth Engine platform, and then how you can easily export this map as a TIFF format. So basically in this time I also try to show you that for how you can easily export the TIFF image of land cover classification map. Then we also try to focus the air quality monitoring some data set from Sentinel-5 and try to make the concentration map of carbon dioxide, sulfur dioxide or nitrogen dioxide. Okay, and then finally we also try to show that how you can easily filtering and displaying the Sentinel-2 imagery, and using the Sentinel-2 imagery how you can easily calculate the NDWI. Okay, so basically this is our today's course content. Okay, so we'll try to start. So first of all, introduction to the land cover classification map. So mainly we can use the land cover data. So basically it's the observe the biophysical cover of the earth's surface, and we can use the land use and land cover data and make the document of the land use trend and change. We can using this data set. And mainly when you want to make the land cover classification map using the Google Earth Engine platform, we need to follow some process. So in this time, and this process is the same for all of the satellite imagery, all of the things. When you want to make the land cover classification using the supervised machine learning method, you always try to follow this same process all time. Okay, so first of all, we need to selecting our region of interest. Suppose you want to make the land cover classification map for any region of Dhaka city or other district. You want to make the land cover classification map. So we can easily select our ROI. Then we can easily make the land cover land use map using this Google Earth Engine platform. Then we also need to choosing and filtering the image collection. So mainly in this time, which image you want to need for making the land cover classification map, you have to choose, and you also need to filter. So we already cover the Landsat imagery, how you can easily filter this part, and today we also try to show you that how you can easily make the Sentinel-2 imagery, how you can easily filter this part. Actually filtering process are the same for all of the images, all of the satellite images. It's only some difference in the image properties, because Landsat and Sentinel image, this both image properties are not same. Okay, so third process is that you need to collecting the training point. Okay, so when you want to make the land cover classification map using the supervised machine learning method, then you have to collecting the training point. Okay, this training point you can get this training point from the you can get the training point from this satellite image, as well as if you have on ground truth data, then you can also use here the ground truth data for collecting the training point. Okay, and then if fourth process is that you need to merging all of this training point together. Suppose you can take the training point, some training point you can get for the build up area, some training point you can get for the water body, some training point you can get for the vegetation. You need to merge all of the training point, which training point you want to use for your machine learning method. You can merge all of the training point. Okay, and then fifth process is that you have to make the training data set using this training point and make the spectral signature of the specific band. It's called the prediction band. You also need to select some band. It can be B1, B2, B3, B4. This is the internal band, satellite imagery band. You have to select. Then using this training point, you need to create the spectral signature. Actually, in this time you need to select some band value. Okay, and all of the band value, it's make the training data set. And finally, when you can get the training data set, then we need to make a classifier. So in this time, we can use in Google Earth Engine platform, there are a lot of classifier or lot of machine learning method is available. If you want, you can use the random forest classifier. If you want, you can use the classification and regression trees. If you want, you can also use the distance, minimum distance. So you need to select a classifier, and then you need to classify your image using this classifier. Okay, and you also need to create the classified image using this classifier. After this, you display the result on the map, and you also need to calculate the specific area of each class, how many build up area is available in this time, how many barren land or how many vegetation, all of the classes you calculate the area. And finally, you also, after completing all of the things, you need to make the accuracy assessment. So what is the accuracy assessment? Mainly it is the identify your machine learning method is the good or bad. We can easily identify using the accuracy assessment. We can also use here the mainly in this time I also try to show you the confusion matrix method. So we can also create the confusion matrix table from our data set using this classifier, and then we can also make the overall accuracy, calculate the overall accuracy, and try to assessment the what is the accuracy of this map. Okay, so basically this is the process when you want to make the any land cover classification map using the Google Earth Engine platform. So in this time we just follow one by one step, and then we can also try to make the land cover classification map. So in this time I simply go to my code editor. So I simply open my new code editor. So first time I also need to select our region of interest or ROI. Okay, so in previous class I already show you that how you can easily import your shapefile or other things. So in this time I simply import my region of interest or my boundary shapefile from the asset tab. So here you can see this is the asset tab. So I simply go to this asset tab, and suppose I want to make the land cover classification map for the Dhaka city. So I simply go to this Dhaka city shapefile. You can see I already imported in my asset tab. I simply click to the import. So now you can see the shapefile is imported in my code editor. As a default, it will be showing as a table variable. If you want, you can use here. If you want, you can use here this any name you can easily use. Suppose in this time I use here the ROI. Okay, in this time our first step is done, so we can select our ROI. Okay, and in this time we follow the second process. We need to filtering and choosing our image collection. So in this time I want to select our image collection. Suppose I want to use the Landscape image because we already covered this part. how you can easily filter. So I simply use here the Landsat image. So I simply go to the browse data catalog and I find out the Landsat image, which image I want to need for making the land cover classification map. So I simply open this data set and go to the Landsat. So in this time I want to use here the Landsat. Suppose I want to use here the Landsat 8. So I simply click on the Landsat images for making this land cover classification map. So you can see this is my image collection. I want to use this image collection for making the land cover classification map. So in this time I simply copy this Earth Engine snippet because this is the unique ID of this image collection, and then I simply paste in my code editor.
So one thing that why you just choose top of atmosphere?
Yeah, so it actually you can use any satellite imagery, not problem. So when I want to get the top of atmospherics, then I can get the top of atmospheric imagery. If you want, you can also use here the surface reflectance or other any satellite image you can use. It's depend on your research paper work or research project work.
In case of land use classification, this one will be the best option, or
yeah, so basically maximum you can see maximum journal or paper, they are maximum use the top of atmospheric data set, and also I can find some paper they are also use at the atmospheric or they are use the surface reflectance data. Okay, so it's totally depend on your research or project work. Actually it's the two sensor. Some sensor I take the satellite image from the top of atmospheric, some sensor take the satellite image for the surface reflectance, some image we also get from the raw image. Okay, so but all of the image, all of the things will be same process. Okay, if you want you can also use the another image, then you can should follow the same process, it will be work.
okay, thank you.
So I simply already copy this. Okay, so in this time I simply copy, and then I simply, you can see, simply copy this Earth Engine snippet and then paste here, and then I simply give a variable name. So my give variable name is that, you can use any variable name. I simply put the variable name is the L8. Okay, so in this time my image is stored in the L8. I just filter it. So I simply take a variable and give the variable name is the image. You can use any name. Then we already covered this part, how you can easily filter. So I simply call my collection L8, then I use here the filter bounds. Filter bounds, it will be filter bounds with ROI. Okay, then I also use here the specific suppose I want to need for the filter metadata, for filter my specific time image properties or metadata I want to filter. I want to use here the cloud cover, then I simply put here the less than, I need the cloud cover less than 1. Okay, then I also use here the another, suppose I want to create the land cover classification map for year of 2020. I simply use here the suppose, okay, so I want to make the 2020, no problem. So 1st January from 2020 December 31. In this time if you want you can also use here the single image. Okay, suppose you want to need for the how many images available in this time, you can see we already covered this part. I also try to show you again. So I simply copy this image and then I simply use here the size function, then I can get how many images is available for my region, which image is the less than 1% cloud cover and stay between this year. I can get the total 7 images. I want to check suppose a specific image date. Okay, so I want to check when this image is the capture, because this same image is not captured at the same time of this month of this year. Okay, so you can see it will be take the different time period. You can see it will be take the different time period. So you can see all of the time period you want to, you can see. Suppose you want to need the land cover classification map for the year of 2020 11th February first image. You can see you want to use this image for making the land cover classification map only for the single image. If you want you can also use this image, no problem. If you want you can also use for this image for year of 2020 26 January, you can also use this image. Okay, so it's totally depend on you, so which image you want to need, but you also check it this image is the cover your area or not. Okay, you can see some image is not cover your full region. Okay, then you also want to check all of the image, which image is the cover your area, then you can use this image easily for making the land cover classification map. But in this time I want to simply take all of this image. From all of these 7 images I want to take the median image, and then I want to create it the composite, and I want to make the land cover classification map. But it possible if you want to use the single image, it's also possible. For using this single image you can easily make the land cover classification map. So I simply use here the median function. I want to take the total 7 images median pixel value and create only for the one composite, and it will also clip with my shapefile. This is the RY. Okay, so let's go. We have to display this satellite image in our map. So I simply use here the map dot add layer. So anyone can guess it, what is our object name in this time in here? What is our object name? I want to show the image of satellite image. Can you guess it, what is our object name? Anyone? Image. Okay, so in this time I can simply use here the image and then paste here, and I add the visualization parameter later. Okay, so I simply click on the run. You can see a new layer will be added here, but I did not see this result. Okay, so in this time I want to use here the center focus. I want to focus in the center of the shapefile. I simply use here the map center object and then use here the RY, and zoom level I put the zoom level is the suppose 10, and then click to the run. So now you can see it will be focusing our shapefile, and you can say I can get this image, but this image is not showing good because I did not add any visualization parameter. So it in this time it's showing the default visualization. I want to change it, and I want to use here the true color composite. So I simply use here the red band, then green band and blue band. Also increase the state 98%, and then click to the apply. So now you can get the better looking of this satellite imagery for Dhaka city. I can easily use this image for making the land cover classification map. Okay, so you can say I can get this image. Okay, and in this time I also import. You can see this visualization parameter is not import in my code editor. So I simply click on the import. You can see in this time it will be imported in my code editor. So I simply copy this name, and we already know about that. After the object name we always put the visualization parameter name, and after the visualization parameter name we always put here the layer name. In this time it's showing the only for the layer 1. I want to show the layer name. This is the true color. Okay, so in this time you can see now this layer name is the true color. Okay, we can get this layer. So our first step and the second step is the finished. Then in this time we will move to the third step. Third step is that we need to collecting the training point for each classes. Suppose in this time I want to classify it from this map. For I want to classify water body. I want to classify the build up area. I also want to classify the vegetation. I also want to classify the barren land. Okay, so I want to take the 4 classes training point one by one. So in this time I want to take the training point using the marker tab. I want to take the training point using the marker tab. So I simply click on the marker. You can see a geometry will be added here, and then I simply click on the edit properties layer, edit layer properties. Simply click to here, and in this time you can see this. First of all I need to make a name. Okay, so I simply put the name is that, suppose I can take the name is the water. You can use any name, but as in this time I want to take the training point for the water, that's why I simply put the name is that water. Then import as it will be feature collection. I want to get the lot of some training more than one training point, so that's why I simply take the it is the feature. I will get the feature collection because the lot of training point I want to get from the water body. So then property. So property is the name. So in this time you can use any name as a variable, but I simply put the class. Okay, you can use any name, but property name will be same for all of the classes. Okay, suppose when you want to take the build up area, you can also use the same name. When you use the vegetation training point, you can use the same name. Okay, and then you after this you also need to add here the value. Suppose if you want, you can also start from the 1, no problem, but if you want you can also start from the 0. So in this time all of the training point for the water, I assign the value is 0. Okay, in this time I simply click to the OK, and then from the satellite images I want to take the some water body training point. Okay, so in this time I simply easily understand this part is the water, and sometime you also did not recognize what is the water, what is the build-up area as an unknown place. Okay, then we also need to try to the another method. Then we also follow the band combination. In this time here I use the natural color or true color composite. Okay, using the B4, B3 and B2. But when you use the another color, then we can also easily identify the another feature of the land cover of this satellite images. Okay, then we can easily identify where is the water or not. Okay, so we also try to discuss about the band combination. Just a minute. So I simply take the training point for the water body. Okay, so in this time, so as a small region you want to need the training point more than 30, it's better. But when you want to take the big region, suppose you want to need the map for the whole country boundary of Bangladesh, so then you also try to make the training point more than 100. Okay, so this is the small region, so that's why I simply take the suppose. Okay,
And there, while choosing that water body, that river are there and some ponds are there, right?
yeah.
So,
So in this time all of the water I in this time I recognize the all of the river water.
okay. So is there any rule of thumb that how many points for any square kilometer or any that kind of things is there, or randomly as per
It's totally randomly. When you want to work with the big region, you can also check it. When you want to check the accuracy assessment, you can
Oh,
check this accuracy is not good, then you can also increase your training point.
okay, got it, yeah, got it, yeah.
Yeah, so I simply take this training for the water, and then I also take the another training point. Suppose I want to take the another training point for the build up area. I simply click on the new layer and then click to here edit properties. I put the name is the suppose build up. Okay, then I simply take the feature collection and property. This property name is the class. Okay, and in this time I set the value is the 1. So all of the training points for build up area I assign the value, this value is the 1, and then click on the OK. Okay, so click on the OK. Okay, so I simply take the training point for the build up area. Okay, okay, then I also take the training point for the vegetation. Simply click on new layer and then click to here, and then I simply take the vegetation. Okay, and then import that feature collection, and property will be class, and value is that I simply put the value 0 and 2. Okay, then click to the OK. So in this time I take the some training point for the vegetation, but in this time I didn't easily recognize the where the I can get the some green pixel level in this here, but I want to need the more accurate result. So in this time I want to use here the another band combination. Which band combination is the better for analysis the vegetation? I want to use this band combination, and in this time I simply open a new link. So band combination, see the different types of band combination. Okay, so you can easily go to this link, and here in this link you can find out the some band combination, different types of band combination, and which band combination is the better for which identify classes we can easily identify. So here you can see, so this is the band combination. You can will already use this band combination. It's called the natural color. So mainly we can use here the red, green and blue, B4 and 4, 3 and 2. Okay, so mainly it will be showing as our human eyes can see, and healthy vegetation is the green and unhealthy flora is the brown. Urban feature appears the white like this and gray, and water is the dark or blue or black. Okay, when I use this band combination, I can use this feature like this. And when I use this band combination, you can see 543 near infrared, red and green band. Then I can get the result like this. In this time, mainly you can see, mainly this band combination is useful for analyzing the vegetation. Okay, and this band combination, you can see red area identify the better vegetation or healthy vegetation, and dark areas are the water, and urban areas are white. Okay, so you can use this band, easily use this band combination, and you can easily identify the vegetation. Here you can see the red pixel value, it's identify the healthy vegetation, and when I use the you can see the black, it will be identify the water. Okay, okay, so I can use this 543. So I simply go to my code editor, and then I simply click on this here, and in this time I want to set the band combination 5 4 and 3, and also increase the state 98%, and then click on the apply. So now this band combination will be added in my code editor, and from this code editor I can easily identify where is the, you can see water body as showing the black color. Okay, also you can see the better vegetation or healthy vegetation is the showing the red color. Okay, so I simply take the some pixel value for the red color. So I already select the vegetation, you can see. Then I simply take the some vegetation training point for this time. And if you have the own ground truth data, you can also easily import the ground truth data in Google Earth Engine platform, and you can easily get this map. Mainly we can use the ground truth data for identify the cropland or cropland classification. Okay, so I take the some training point for the vegetation, and finally I also take the some training point for the barren land. So I simply click to the new layer, and then click to here, and then I simply put the, and then I simply use here the feature collection and property name is the class, and in this time I set the value is for free. Okay, so I simply click to the OK. So now I take the some training point for the barren land, and you can see there are a lot of combination. When you use this band combination, then it will be easily identify. You can see composite the vegetation shade of green, then while darker shades the green indicator the dense vegetation, sparse vegetation, lighter shades urban as the blue, soil of the various shades of brown. Okay, when you can use this band combination 652 band combination, so mainly we can use this band combination for identify the agriculture feature like this. Okay, also you can see the geology. When you want to identify the any geological feature, then you can easily use this band combination and get the geological feature. When you want to use the bathymetric, then you can easily use this. Okay, you can see there's a lot of vegetation index, moisture index. Okay, we can easily use all of this index, then identify the any individual classes. Okay, from this satellite images. So in this time I want to take, suppose, okay, so I will go to my true color composite and identify the barren land. And the another is that if you want, you can also use here the different types of indices. Suppose when I use the indices for NDVI, it's help to me identify the vegetation. When I use the NDWI, it's help to me identify the water. When I use the built up index, it help to me identify the built up area. Okay, so okay, so I simply use here the true color composite again. Suppose P4, P3, and go to the F. Okay, so in this time I simply take the some barren land from here.
And one thing that while making this class,
Yeah,
uh, if we can we reduce that opacity, that value of showing there is in different band composition is given, right?
yeah,
Just
yeah.
like in GIS, there is base with the base map, we can use different layers, just like street map or other things, to exactly point out whether my point is exactly correlated with
Yeah,
the
so
next.
it's possible, but when you want to present time, suppose in this time if I want to use this satellite image, you can see, then I also get the better view, okay, for this region. But this satellite image is the cover the area for present time, okay, year of 2020 22, this satellite image, the base map, okay. But in this time here I use the satellite image for the year of 2021, okay.
Okay, yes,
So
yes.
but when you want to use the suppose you want to present time map, you want to make the land cover classification map, then you can also use this map for helping the satellite map or other base map, okay.
Okay, okay.
And I want to just merge all of this training point together. So this is our fourth process, you can see. So we already covered selecting our ROI, then choosing and filtering our image collection, then collecting our training point. In this time I need to merging all of this training point together, and then we also need to make the training data set. So in this time I simply make the merge all of this training point using the merge function. So I simply go to my code editor. Okay, so I simply go to this code editor. So I simply take a variable name. Suppose I take this variable name, suppose training, you can use any name, no problem. Then I simply merge, I simply write the name, suppose water, then use here the merge. It will be merged with suppose built up, and it also merge with vegetation, it also merge with barren land, okay. So I merge all of this training point. So now I want to check what is the, I want to check it how many training point I want to get from this in this time. So I simply use here the print function, and then I simply use here the training, this variable, and paste here, and then click to the run. So now I want to get all of the things about this, you can see. Okay, so it will be working. So I take the feature collection. Here I can get total 192 training point for all of the classes, 192. So in this time, if you want to check, you can say simply click to here and then click on this feature. And from this feature, I want to get all of the property with their class. Suppose you can see here the total was from the 0. I want to get the total 192 training point for all of the classes. I want to check it for the number 38. What is the point? What is the training point for this class? I want to check it. Simply click here and click on the properties. You can see this is the class 0. So class 0 means that this training point for number of 38 training point is for our water body, because when I want to take the value, I put the value is the 0. Okay, so all of the training point 0, it's represented the training point of water. So I want to check the another, suppose you can see what is this, you can see class 1. So I can see that this 78 number training point is represented the 1. so that's it will be just built up area training point. Okay, so all of the training point we also add their class with their value, so that we can easily identify. Okay, you can see this is the class 3, so it's identify this is the barren land. Okay, so when I want to take the training point, I can get the value 3. Okay, so here I want to get the total 192 training point. In this time I want to create a prediction band. Suppose in this time I want to add here the some band, then I want to take all of the training points, their bands value, and I want to create the training data set using this band value for individual. So you can see here at 192, in this time I want to add here the some prediction band. This prediction band help me to take the training point pixel value. Okay, so in this time I simply just take this training point. So for this, okay, so I simply use here, I want to create the training data, so training data set. So I simply take a variable. Suppose I give the variable name is the level, and in this level variable I stored a property name. So in this time I use here the property name is the class. So next I simply store this name is this class, but it's not compulsory, but I can simply use this class. Now this property name is stored in this variable level. Okay, then I also need to use here the another things. This thing is that I want to need some band, prediction band I want to need. So I simply take a variable and give the variable name is the bands. Okay, in this band I want to make a list all of the band, which band I want to use for taking the spectral signature. So I want to use here suppose B1, then B2, then B3, and B4, and B5, also B6 and B7 band. You can see in this time I want to use only for the internal band. This band is already presented in the in this satellite imagery. All of the band will be satellite imagery, it's already present. So in this time I use here the only for the internal band, but if you want you can also use here the some external band for your more accurate land cover classification map. If you want you can also use here the another band is the NDVI for get the signature or pixel value for the vegetation better. You can also use here the NDWI for get the water index. You can also use here the BI index. You can if your region has the some snow, you can also use here the NDCI index, NDSI index, normalized difference snow index. Okay, you can use the also created some external band like this NDVI, NDWI, BI, NDCI. So if you want you can also add the some more index to get the better land cover classification map. But in this time this is a totally introductory part, so that's why I simply use here my external band only for. So I simply remove all of this band. Okay, so I want to develop this model using this band, which band already exists on the satellite images. Okay, so in this time I want to use here.
There are also other internal band, right?
Yeah,
Just
yeah.
like B8, B9.
Okay, so mainly we can use here only for this. You can see we can only for this you can only for this you can see 30-meter resolution. Okay, you can see this the B9 is that you can see this is the SIRAS mainly description you can see. Okay, and also 50 meters. So in this time I can use here this 30-meter resolution pixel value with this wavelength, and in this wavelength we can easily identify the spectral signature for better signature for this land cover classification map. Okay, so in this time I ignore this internal band, and I only use for the internal band. I ignore the external band. But when if you want you can also add here the some external band for your more accurate of land cover classification map. So in this time I want to add here the another thing is that I simply use here I take a variable and give the variable name is that input. Okay, in this input I simply call my image. you can see I already filtering and choosing my image, and it is stored in a variable image. I simply call the image, and then I simply paste here the image. Okay, in this time I simply use here as a select function, select, and then I simply select my bands. Okay, I simply select these bands. Okay, in this time I already select or make a list for the bands and stored this variable band, so I simply use the select. So this is my input, and you can see this is my image. From this image I want to select this band, and I already filtering and choosing my image and stored this image variable. Okay, in this time I just created the spectral signature using this prediction band for this image. Okay, so just a minute, and just a minute, 1 minute, I take a phone. Okay, so in this time I want to make the spectral signature of this training point. So for this I simply take a variable. I simply, you can use any variable name, so I simply take the variable. I can use the variable train image. Okay, then I simply call my image with the band. Okay, so I simply call the image with the band, and in this time I simply use here this input. You can see this image and this band I already stored it in a variable input. Okay, so I simply copy and then paste here. After this I simply use here the sample region. Okay, sample regions is a function, so mainly this function help to identify or help to getting the spectral signature from this collection or from this training point. Okay, so I simply press on the control and space. Here I can get, I simply press on this, you can see I make a dictionary also. Okay, so in this time I just input all of the argument and keyword and key value. So first of all, collection. So collection is that which training point you want to need for this spectral signature. You can see I already merge all of this training point and store in a variable training. I simply copy and paste here. Okay, then properties. So you can see when I want to take the training point for all of the classes, I simply put here the property. Okay, you can see I use here the property name class. Okay, and this class property name I already stored it in a variable. This variable name is the level, so I simply use here the level. Okay, Okay, then scale is that your resolution of the satellite images. In this time here I use the Landsat. Okay, so for this I simply use here the 30-meter resolution, and other things. In order for this time I simply remove all of the things. In this time I want to check it, my training data set. I simply use here the print, and then I simply use here the train image and paste here. Okay, you can see in this time I want to get all of this training point with their band value, all of the band value. For each point I want to get all of the band value. Okay, so I simply click to here, and you can see picture. Suppose you can see point number 1 for 0 refers to the first item. I simply click here and then click to the properties. Here I can get, you can see b1, b2, b3, b4, all of the band value I want to get for the training point 1, and this training point 1 is identify the class 0. It means that it will be identify the water. Okay, so I want to get all of this training point. If I want to check for 24, you can see I also get the training point, all of the training point for the class 0. Okay, and this training point is the 24 for the water, because this is the class 0. Okay, so every individual training point I want to get all of the band value, all of the spectral signature I want to generate. In this time I want to just use here the machine learning or classifier. Then I can easily make this classified image using this data set. So you can see I create my data set. So this is my data set I create. Okay, all of that spectral signature I want generated. So in this time I want to use this data for created the land cover classification map. But in this time I also separate this data. So I want to separate this data because I want to use some data for making that, for train my model, and also use some data for test my model accuracy. So I want to, suppose I want to use here the 80% data for train my model, and 20% data for checking my validation or test my validation or accuracy. I want to observe the accuracy using this 20% data. So accuracy for the checking this model is the good or bad, which model I want to use. When I want to get the bad accuracy, I remember this model is not good. Okay, when I get the better accuracy, then I think this model is the good or better. Okay, so in this time I want to need some data. I want to separate this data. It will be just totally randomly. Okay, so I want to get the data, 80% data for training my model, and 20% data for testing my model is good or bad. Okay, so in this time you can see I already created my data set, and this data set is stored in a variable train image. So in this time I want to just created the 80% data randomly and 20% data for randomly take. Okay, so I simply take a variable and give the variable name is the train data. Okay, and then I simply call my all of the data. You can see train data. I simply call this train image. Okay, I want to get that 80% data and 20% data randomly. I not selected this data is for training, and this data is for the testing. I not selected. Okay, I take the data randomly. So that's why I simply call the train image and paste in here, and then I simply use a function. This function is the random column. Okay, in this time I want to get the data randomly, 80% and 20% data. Okay, so first of all, suppose I want to get the data of 80% data for using training. Okay, I simply take a variable and give the variable name is that I can use the variable name is the train set. You can use any name. I simply train set, and then I simply call the train data, because all of the data now is stored the randomly in here. From this I want to just filter the 80% data and 20% data, then I easily separate the data. Then I use the train data for making the train my model and created the land cover classification map, and rest of 20% data I want to for checking my validation. If you want, you can also use here the 70% data for training and 30% data for testing. Okay, so it's totally depend on you. And then I simply use here the filter function. I want to filter it. How can I simply use here the earth engine filter? I simply use here the earth engine filter. So I simply use here the earth engine filter. Then I simply use here the less than. I simply use here the I simply use here the less than. I take the data randomly. I simply use here the random. I use here the 0.8. Okay, and then rest of this data I take this time 20%. Rest of 20% I want to use for checking the validation. So I simply use here the data for validation, okay, or testing my model. In this time I take a variable and give the variable name is the test set. I want to use this data only for checking my model, it will be good or bad. And then I simply call my train data, and then I simply paste here, and then I simply filter it. It's a dot filter, and then I simply use your earth engine filter dot. In this time, first time I use here the less than. In this time I want to use here the greater than or equals. So I simply use here the greater than or equals. Okay, greater than or equals. I simply put here the random 0.8. Okay, so rest of 20% data now added in my test set. Okay, so I simply separate this data for the two way. I want to use here the 80% data for train my model. I can use the different types of model for random forest. Then I also use here the minimum distance, and I also use here the classification and regression model. Okay, so I simply separate my data two way: 80% data for use for training and 20% data for the checking the validation or testing. So now I simply use this data for train my model and use this data for check my validation. Okay, so now in this time, in this code, if you have any question or any doubt, you can ask me. Anyone any question or any doubt about this? Any question, anyone?
Yes. You have 80% for the train data.
Yeah.
And 20% for the test data. But in your filter, you have random 0.8 for the train and 0.8 again for the test. Should it
so
not be
in this time I want to take for the rest of data. Okay, after taking the 80% data, then greater than or equals, then get the